Good morning, afternoon, and evening. Today, class, pupils, we are going to learn about how to use quadrilateral properties appropriately to figure out interesting things. So, for instance, in this problem right here, we start with the givens. We should really start with that first given. For some reason, even though we're listing it first, it is the most important. Students skip it. So what we're going to do is we're going to react to the fact that this shape over here is a rhombus. We know that all sides are congruent in a rhombus. Another very important fact of a rhombus is that the diagonals are perpendicular. That is of the utmost importance. Okay, what else do we know? Well, we also know that since a rhombus is a parallelogram, we do know that the diagonals bisect each other. Also, in a rhombus, the diagonals bisect each of the angles. Now, there's even more to what I'm doing here. What I mean by that is that notice how not only is the diagonal bisecting this angle into two congruent parts, but these angles are the same as these angles. We do know that non-consecutive angles in a parallelogram are congruent. That also happens in a rhombus because a rhombus inherits all of the properties of a parallelogram. Super important. So same thing here. This entire angle is the same as this entire angle. That's really, if you apply same side interior angles or supplementary a few times, you'll actually kind of get to this. But so just don't forget that each of these portions of this angle are the same as the portions of this angle. So there are a lot of interesting, important properties. So notice how I didn't dive right in and just write x is 4x plus 10 somewhere, whatever. I did not do that. You must slow yourself down and react to the diagram. So just to really hammer this point home, and so that you can get full credit on your video, what you'll need to do is you'll need to write at the bottom of this slide right about here, you'll need to write your first name, comma, don't forget to react to the givens. So that's the message you're going to write yourself. So for instance, if I were taking notes, I'd write a little note right here. I'd say mark, comma, don't forget to react to the givens. So pay attention to that detail. Not only should you write that on your video to get full credit, but you should also do it forevermore. Okay, so now this problem is going to be easy. Why? Since we reacted to the given, now when we put the information in the algebra, if you will, equations jump out. Look at that. I wrote down one thing and I already know an equation. Angle CBR is 4x plus 10, but it's also 90 degrees because the diagonals of a rhombus intersect each other perpendicularly. Alright, so that's nice. So now I have an equation. I can get x now. So I labeled in that given, and I have an equation for x. If I subtract 10, divide by 4, boom, x is 20. I'm already halfway through the problem, and I haven't even labeled everything yet because I've been so careful to react to what I was given. And you will get more complicated problems than this, but I'm really just reiterating the fact that you should react to the givens and write in all markings before you ever write in anything with an X on your paper. Alright, apparently I think that that's really, really important. Alright, also NA is 3x plus 5. Oh, well, now that we've got an X, we can plug that in. So if we plug in a 20 right here, 3 times 20 is 60, plus 15 is 75, we can actually get the perimeter of crayon. We've got 75 on each of the sides. We know that all of the sides are congruent, so we can just multiply 75 by 4. 75 by 4 is 300. So the perimeter of this, we would say, is 300 units. What we mean by that is like units of distance or units of length. So since we never said if we were measuring in feet or meters or, decameters, who knows, we'll just say that our answer is in units. So this problem should have gone quite nicely. Always know the properties of the shape you're dealing with and mark them in accordingly, because then the equations just jump out at you. A really popular, important one, or important idea, is that the diagonals of a rhombus are perpendicular. Also, the other big deal of a rhombus is that all sides are congruent. You should know that one like the back of your hand. So this problem, wasn't so bad. So in this problem, we are given that we have a rectangle called quad. Do not pass go, do not collect $200, mark up your diagram. Well, in a rectangle, opposite sides are congruent, similar to a parallelogram. However, all of the angles of a rectangle are right angles. So all interior angles are 90 degrees apiece in a rectangle. That's hugely important. What else is important? Well, in a rectangle, the diagonals bisect each other in such a way that, they intersect each other in such a way that they actually bisect each other. So every single portion or piece of these diagonals is the same length. That's crucial. This to me looks like a barn door, and it literally, regrettably, it's drawn to scale, so even if it wasn't, you should know this, but seeing that it's drawn to scale, it really looks like that happens. The diagonals bisect each other, and the diagonals are congruent. So that's kind of interesting. What that means is QA is congruent to UD, the diagonals are the same length, but also each little piece of each of the diagonals is congruent in length. So that's kind of cool. Okay, so notice in this problem I didn't even say anything about UD or QR yet. Why? Because I wanted you to react to the givens. Okay? So from here we can now I'm going to give you each of the givens one at a time so that we can start to come up with equations and not distract ourselves by the x's. Okay, so we completely reacted to the fact that this is a rectangle. Now we can mark in that UD, now I'm going to use red for this, UD, that's going from here all the way to here, that UD is x squared plus 5x big. Okay, that's that entire diagonal. Okay, so we marked it in. Now, notice how I made like a sort of brace thing that sort of looks like a pterodactyl or something. I'm using it to show that that entire diagonal is x squared plus 5x big. Be careful, if you don't show that on your paper, you might miss that detail and make an incorrect equation somewhere along the way. Alright, so in addition, I will tell you, after you've marked in all the information you have, that QR is 2 minus 4x big. QR is 2 minus 4x big. Now notice I'm not going to use a brace or something to show that it's the entire diagonal because it's only a portion of it. So I kind of wrote it somewhere in the middle of that portion. So we need to, in this problem, find x and QA. Well, let's state something very important about this rectangle. And you really should brag on paper like this, even when you're not watching a video. You should say the diagonals of a rectangle are congruent. You should say that. That's going to help you realize this relationship. Notice how we gave you information on the diagonals. Well, the relationship would kind of work like this. One entire diagonal, x squared minus 5x. Notice how I made a copying error here. It's important to make mistakes and be able to catch or recover from them. So be careful. This is a minus, just like it is up here. So just make sure you're copying that down appropriately. Excuse me. One entire diagonal, namely UD, is going to be congruent to the entire other diagonal. Now notice QR is not the entire diagonal. So, in order to make this statement be correct, we'll have to double the length of QR to get the entire length of QA. We know QA is the exact same length or distance as UD. So if we double one little piece of the diagonal, we will get the entire other diagonal. And the diagonals are congruent. So this should make sense. QR is half as big as UD. QR is half as big as QA, and QA is congruent to UD. So we have this relationship here. This relationship is crucial, and you really do need this 2 here. QR is half as big as this entire diagonal. We know that both diagonals are a length of x squared minus 5x. So we've only gone halfway. If we were to double this, we'd have the entire length. Okay, so now as a little bit of an exercise to the reader, or viewer, or pupil, meaning you, from here, to get full credit on this video, I feel like I do this a lot, you will need to distribute this 2 to each portion, and then you're going to end up factoring because we have a quadratic here. You're going to bring everything to the left-hand side via subtraction or addition so that you have x squared plus some stuff equals 0. Once you have your quadratic in standard form like that, you will need to factor. In addition, your goal is to find out how big QA is. When you factor, you might get 2 values of x. In order to get full credit on this video, you must solve this completely. You may have values for x that you'll need to reject. What I mean by that is, if you plug in one of the values for x that you get, you may end up with a negative side length. You must reject that x value. Keep in mind, it's okay to have negative x values, it's just not okay to have negative lengths or distances. So check your answers, perhaps only one of them will work, and then finally answer how big QA is. Good luck. Call your friends if you need help. So in addition to finishing up the last problem for full credit, you must crush this problem as well. Now, in order to appropriately deal with ABCD being a square and all this other information, pretend that all you see is ABCD is a square. Mark in all the properties that you know about a square, and then go further from there. Find the perimeter, and lastly, find the measure of angle AEB. Keep in mind that there is a lot that you need to do to get full credit on this video. It should go rather swimmingly, though, so just make sure you're paying attention to details, and good luck.